What's up, chemistry class? Welcome to your next bit of notes for stoichiometry. We're going to convert from moles to grams, and then also atoms to moles as well. And so by the end of this, we're going to be able to take or quantify, if I had a handful of sand, how many moles would that be? And then also how many actual molecules would be in my hand. And so sit tight for me, and we'll help. And would love to help you unpack this. If you have any questions, as usual, let me know. Sometime during my office hours, you're welcome to either hop on for a quick Zoom or talk about it face to face. Next week, sorry. Okay, so let's go ahead and unpack this a little bit. We have the mole. Now the mole is a number, right? And so we're actually going to unpack this number, and we're going to use it as atoms or molecules here. Okay. So what we're going to do now is what we're going to do, but we did before, looking at moles to moles, kind of converting, and we're going to look at maybe moles to atoms today and how that conversion actually happens. So how many atoms are in blank in 1.5 moles of oxygen? So let's go ahead and type out what we have. You'll always, always, always start off with what you have. We have 1.5 moles. Let me write that just a little bit bigger. We have 1.5 moles of oxygen. Okay, and like every sort of dimensional analysis conversion type problem, whatever unit, let's do this in highlighter, remember whatever unit's going to go right here is also going to go right in here. So let's go ahead and do that. Let's go put moles of oxygen down here. And what are we going to? What are we trying to find out? We're actually trying to find atoms. Actually, it would be atoms. Yeah, we can do atoms of oxygen. Okay. Actually, no, because that's going to make it a two-step problem. Let's just do molecules. If we're being 100%, I would say true. All right, let's stick with molecules here. Here we go. Alrighty. Molecules of O2. Now, for every 1 mole of anything, that accounts for 6.022 times 10 to the 23rd of that thing. So this is why having a scientific calculator in hand is going to help you out, is because these numbers are going to get very big. We're going to do 1.5 times, and here's how I'm going to type this in my calculator. 1.5 times 6.022. Now there's a EE button on my calculator. This EE means times 10. Times 10 to the 23rd. Okay. Now, yeah, because this means times 10 to the power of. So this is the nice little shortcut. You don't have to type out all those characters. So I'm going to do 1.5 times 6.022 EE, but it also pops up in my calculator as just E, but this is called the EE button. I don't know the difference. E times the 23rd. Yep. So we're going to have 9.033 times 10 to the 23rd. So if I were to have 1.5 moles of oxygen, it would actually be this many molecules of O2. Now, to put that in perspective, how many molecules would that actually be? Let's count that out. So it's going to be 1, I start with one number, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That is a big, 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 big number. Okay? So if I were to breathe in All right, 1.5 moles of oxygen, which really isn't too much. You're actually bringing that many atoms or molecules worth. And so that's when we're looking at the moles and we convert stuff. We use moles rather than actually molecules just because the numbers are very, very, very large. But let's go ahead and try another one first. If I have 3 moles of water, how many molecules of water will I have? Well, we're going to start off with 3 mole of H2O. And we're going to use the exact same conversion we did before. Moles of H2O, we're going to go down here because we want those units to cancel. And I'm going to molecules of H2O. So for every 1 mole, we have 6.022 times 10 to the 23rd. These cancel out. And I'm just going to type this in my calculator. Follow along with me. Make sure that you are understanding how to type this in your calculator as well. If not, that's the point where we need to have a conversation on how to help you out. I got 1.8066 times 10 to the 24th molecules of H2O. Okay? All right. What do we do with this next, though? Like, how do we actually get to a quantifiable number that we can use in real life? And that's grams to moles. So grams are a measurable quantity in the lab. We can use a balance. We can use some scales. But how do we figure that out? Well, this is the part that's called the molecular mass. So it determines grams per mole. So if we look at the periodic table and we find hydrogen has an atomic mass of, I'm going to use 1. Well, it's not actually just 1. So let's hop over to the Googles and let's see if we can unpack this just a little bit more. Looks at ptable.com. All right. Hydrogen actually has a mass of 1.008. So I'm going to use that number. So I'm going to use 1.008. All right. And then oxygen has a mass of 15.99. But here's the thing is that I really don't care too much about these types of numbers when you're looking at specifics. So we actually can go ahead and round these off and make them nice, smooth, even numbers. So instead of using that, we're going to use 1. And instead of this, we're going to use 16. Okay, but remember, this is H2O we're going to deal with. So, actually, sorry, I'm getting ahead of myself. We're going to be finding out the mass of H2O. So H2O has 2 hydrogens. So it's going to be 1 times 2, because the mass of hydrogen is 1. There's 2 of them, so it's going to give us 2. Then we're also going to have oxygen, which has a mass of 16, and there's 1 of them. So we actually get the molecular mass of H2O to be 18 grams per mole. That's it. That's why that number at the bottom of the periodic table is so important. It helps us figure out the mass of something if we had a mole of it. So if we have 18 grams of water, which is really just 18 milliliters, really not much, you have a mole. How do we use this number? Well, let's practice and let's try it out. We have 13 grams of potassium chloride. So we got 13 grams of potassium chloride. Now, this is kind of a little bit of a tidbit of pushing you. Make sure you're following with potassium chloride. What would that be? That would be K, which is a plus, Cl, which is a minus. Give me KCl. Okay? I might just give you the names. I might not give you the molecules. So, KCl. Okay. Now we have to find out what is the molecular mass of potassium chloride. So KCl, let's look at it. K, what is potassium? Potassium is 39. So look in the periodic table, it's 39 and there's 1 of them. What about Cl? Chlorine. Chlorine is 35.45, so that rounds to 35. So we get 39 plus 35, so it's going to be 6074. Is that right? Yeah, man, I'm late. And that's grams per mole. Okay, so now let's do this. Remember, everything that's right here is going to go down below. So we're going to go grams of KCl. And we're going to go to moles. That's what we're looking for. Moles of potassium chloride. So, one last thing. Where does this 74 go? Well, let's see how the 74 is next to the grams. It's going to go next to the grams for 1 mole. All right. These units cancel out as usual. So what I get is 13 divided by 74. And this gives me 0.176 moles of KCl. All right, that's it. Let's try the next one out for me. Okay, lithium oxide. What is lithium oxide going to be? And if you have 24 grams of it, how many moles of that would it be? Well, lithium oxide, you should be able to predict what it is, and that's, Li2O. And let's figure out its molecular mass. So lithium, oxygen, lithium and oxide. Lithium, there's 2 of them. And let's find the mass of it. So the mass of lithium is 7. So that's 14. And then we have 1 oxygen. That's going to be 16 times 1, still give me 16. So the molecular mass of lithium oxide is going to be a 2030 grams per mole. Is that right? Yep. Okay. Now over here, whatever's in this right here, up in the top, we're also going to do down here on the bottom right. Grams of lithium oxide, 2 moles of lithium oxide. So 24, 30 goes with the grams, 1 goes with the mole. That's it. Bob's your uncle. These cancel out. All you need to do is punch it in your calculator, and you have 24 divided by 30, which should be a pretty number. Yeah, 0.8. 0.8 moles of Li2O. Okay, we're hopefully looking better. Let's keep on going. And let's make this a kind of a next level more difficult. All right, where are we going next with it? Let's go from grams to atoms. Well, the problem we have here, and now it's going to be atoms again. Let's use molecules. Because you can't have atoms of water, because water's not an element. I digress. Okay, we start off with 500 grams, but we can't go straight from grams to molecules. We're going to have to go from grams to moles, and then moles to molecules. So let's try that out. 500 grams of H2O. How do I go from grams to moles? Well, grams of H2O to moles of H2O, that's using the molecular mass. So H2O down here, hydrogen's going to be 1, and there's 2 of them. Gives us a mass of 2. Oxygen is 16, and there's 1 of them. So we get 18 grams per mole. So 18 grams per 1 mole. Now these gram units cancel out. Let's do that in red. Do I have my final unit that I'm looking for? Molecules of water. Well, no. I have moles of water. Well, how do I go from moles to molecules? Well, for every 1 mole of H2O, we're going to use Avogadro's number, 0.22 times 10 to the 23rd. Molecules of H2O. So moles cancel out now, and now I'm in the final unit of what I want, and that's molecules of H2O. So let's plug this in our calculator now. I'm going to do 500 divided by 18 times 6.022 times 10 to the 23rd. And that gives me an answer of 1.67 times 10 to the 25th molecules of H2O. Oh, it saved on me. Anytime it saves on me, it hops around. So molecules of H2O. So what's up with 500 grams? I chose the number specifically. This is half a liter of water. So if you take half a liter of water, you drink it all, you're actually drinking in this many molecules. That's how small a molecule of water is. So if you drink, let's say, pretty close to half of a regular sized bottle of water, it's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20, 21, 22, 23, 24, 25. That's how many molecules of water you've drank, which is an astronomically large number. And so when you look at atoms, they're really, really small. So that's why we look at units of moles and not have to worry about these other really arbitrary, difficult to track numbers. Okay, let's do one last example and we'll call this done. Is 50 grams of silicon dioxide, which is also sand. Now 50 grams, I kind of imagine if you were to get a big handful of sand, I want you to figure out, I should say, I got all kinds of mistakes. So we're going to look for molecules of sand, silicon dioxide, which is, I want to let you see if you can figure it out. Silicon dioxide is SiO2. Okay, if I were to go to 50 grams silicon dioxide, how many molecules would you pick up in a handful of sand? So let's figure that out. We always start off with what we're given. And so we have to now look at our next piece. How do I go from grams of silicon dioxide to moles? Well, silicon has a mass of 28. So let's do 28. And oxygen, there's 2 of them, and each one has a mass of 16. So that gives me 32. 28 plus 32 is 50, 60. So for every so it's 60 grams per mole. So it's 60 grams per 1 mole. Okay. Now these units cancel out, but I still want molecules, and I have moles right now. So we got to finish this out. So for every 1 mole of SiO2 you have 6.022 times 10 to the 23rd molecules of SiO2. Okay, and then our units cancel. We have molecules of SiO2 left. So let's figure out what that number is going to be. That's going to be 50 divided by 60 times 6.022 times 10 to the 23rd. And this gives me with a final answer of 5.02 times 10 to the 23rd molecules of SiO2, which is a really big number. I mean, that's like what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23. That's how many molecules of sand you pick up in a handful of sand. If that's not interesting, I don't know what will be. But I'm going to call that it for notes. Good luck. If you have any questions, let me know. This can be a little confusing, but you guys are usually troopers and you end up figuring it out. Good luck. If you have any questions, let me know. Take care.